Hey, welcome back to my YouTube channel. I'm Xavier Smith, and in this video, I'm going to talk about explanatory response and confounding variables. So let's get into it with a little diagram. First, our key is A is the explanatory variable, B is the response variable, and C is the confounding variable. So I'm going to go over the diagram and then explain how these could all be used in a practical use, and then go over the diagram again. So A could directly correlate to B, and A and C are connected. Well, so A and B are slightly connected, but they're also heavily connected. But A could also be connected to C, and C could be connected to B. So you're like, what just happened? Well, let's talk about a practical use. So if you're talking about, okay, test scores, or how well a student does in school, right? You're saying, is it the number of books in their house? Like if they have more books in their house, they have higher intelligence or they're better at school, right? Does that just directly affect their test scores, number of books? Well, you could do this study and be like, okay, I'm going to look at these houses, right? I'm just going to pick 50 children, and I'm going to say, okay, now go to your house, tell me how many books you have, and then I'm going to look at your test scores, see how you're doing in school. But there are things that could influence that called confounding variables, which would be like the amount of pressure a student gets from their parents to perform well, right? If they have to perform well, then they might be doing better test scores even if they don't have that many books, right? Or how much they care about their grades. That can also affect it. So that's our little C here. It's A and C, as you see by the dotted line, are pretty connected. They're not exactly A goes directly to C. A means C. But it's A and C are basically the same. They both affect the response variable. So what you want to get out of this, how you can kind of get rid of C is start dividing groups. If you're okay, we have 600 viewers on this video, right? I want to know what they think about it. Well, if I want to say if I want to split up male and female so there's not bias, I'd be okay, 300 male, 300 female. But if I put them all 600, there may be more leaning towards female on one side or something like that. Okay, but the confounding variables, you can get rid of them by something called blocking or stratified random sampling, just so you don't lean heavily towards one of these confounding variables. You're looking at hotels, you're okay, there's street view and there's ocean view, right? If you just take a simple random sample of 10 rooms, 5 of each, you might get, if you're okay, I want to see 4 rooms, what are they thinking on this floor? And there's 5 of each, and there's 10 rooms on the floor. You may get 4 of oceanfront and overestimate, or you may get 4 of street view, which isn't good. So these confounding variables can be spread out by blocking these two different things apart or using more randomized assignment. Okay, so I went on a little tangent there. A is explanatory, B is response, and C is confounding. So we know A correlates to B, right? And A is pretty similar to B. There's usually causation there. But A is close to C, and C also affects B. So your goal here in statistics is to get rid of as many confounding variables as possible to see this explanatory and response variable. So when you're doing something, you're okay, here's your population, right? You can split it up into male, female. Their gender is a confounding variable that might change someone's opinion on something, right? And then you do your simple random sample and you get your data and then compare. But it's you could do it by age. So you're okay, if you just did the population and you did a simple random sample, there's 600 people and you're taking 300 out of them, right? You may get 200 females. And you're how is that possible? The majority are females. You're it should be evened out, but it's not. This is an easier way to even it out and get rid of confounding variables. So what you need to know is confounding variables do affect the response variable. So just try to get rid of them. If there's too many confounding variables, you might have to you might have to say the experiment's not not put together well and therefore is invalid. Thanks for watching, and I hope this video was helpful.